Okay, so today we're going to be looking at Chapter 10, Topic 3, where we're going to actually be testing the correlation. So this is where we bring a hypothesis test to the stuff in Chapter 10. So in almost every sport, teams play games before the regular season begins. While these games do not count in the standings, many people think that a team's performance in these exhibition games are a good predictor of how well that team will do in the regular season. Other people, especially fans of teams that aren't doing well in the exhibition games, suggest that performance in these games tells us nothing about what the future holds. So what we're going to be looking at is the 2009 winning percentages for 30 Major League Baseball teams during spring training and the regular season. So you can see that this is their spring training winning percentage, and here's their regular season winning percentage. So this team, for example, is a team that maybe had a winning percentage of about 46% in spring training, but only maybe about 36% in the regular season. So the correlation was calculated for this data, and R is 0.45. So let's interpret this correlation as we did in the topic 2 notes. With 0.45, we can say that there is and because it's less than 0.5, I can say weak. It's kind of close to 0.5 though, so, and you can definitely tell that there's a relationship. So if you want to put moderately weak, that's fine. We see that it's positive. Anytime that we use R, it talks about the linear association or relationship. Do not use the word correlation to describe correlation. So there's a moderately weak positive linear relationship between our two variables. Our two variables are spring training win percentage and regular season win percentage. Something else that's always nice to talk about is really what that's implying. And as you'll see when we test the correlation, that's really what's important. What this means is that as spring training win percentage increases, that our Y, the regular season, tends to increase as well. So we really see, we really focus on that positive association. That as one increases, the other one tends to increase also. So it's important to note that this is an association that only deals with one season. Remember, it's possible that in general that there is actually no association between the winning percentages, and that the correlation is just due to random chance. So again, we have to note that when we look at the data, we're looking at the performances in one particular year. When we calculate correlation, we'll be finding the observed correlation, an estimate, as opposed to the true correlation. So this is very similar to the observed versus true standard deviation that we did back in Chapter 7. So the observed correlation is based on a limited number of performances and we know that that's going to, that it varies from the actual correlation due to random chance. So the observed correlation is based on a limited number of performances. It varies from the actual correlation due to random chance. So what is the actual correlation? Well, we call that the true correlation. And the true correlation would be based on an infinite number of performances. So because we can't have an infinite number of performances, We know that this exists only in theory. So this is very similar to the idea of performance versus ability. The performance is what we see, like the observed correlation. The ability is what we know exists, but we can never get to because it's hypothetical in nature. So the observed correlation is actually the R value that we find, that we can calculate. And the true correlation, because it's hypothetical in nature, that's what we're going to use in HO and HA. Much like in chapter 7, how we used the true standard deviation in our hypotheses. So that's the difference between observed and true correlation. So this 0.45, that is the observed correlation that we can use. So now we should perform a hypothesis test to see if the observed correlation of performances was because of a true correlation or just due to random chance. So it wants us to state our hypotheses, always plural. We start with our HO, our null hypothesis, and we're going to talk about the true correlation in our hypotheses. So we can talk about the true correlation. That word true is very important. That's what we're hypothesizing about. The true correlation between spring training win percentage and regular season win percentage is what? Well, remember, our null hypothesis assumes no bias, that nothing special is occurring. So if nothing special is occurring, that's assuming that the true correlation is 0, okay? Again, what this does is this implies that there's no association. And that's always what we want to assume. We want to go into this without any bias whatsoever. So we assume that our correlation is 0. Now, the alternate hypothesis, when I first did this surprised me a little bit. But anyway, so we start it the same way. Again, we'll talk about our true correlation between spring training win percentage and regular season win percentage. Is what? Now, if you're like me, I'm a numbers girl, and I'm thinking, okay, well, if I have 0 here, then I'm going to put whatever my correlation was here. That's not what goes here. What we put here is the direction only. It makes no difference whether it is like a strong or a weak or any kind of association. All we're trying to see is as one variable increases, what does the other variable do? So that means that for our alternate hypothesis, we're just going to say that it is positive. Remember that the correlation, the observed correlation that was found was 0.45. That is positive. So we just want to show that there is some sort of positive association. We don't care how strong or weak it is. It's just that there's not no association. There is a positive association. Okay, so that's how we write our hypotheses. We talk about the true correlation. Our null is 0, no association. Our alternate is whatever direction that the observed correlation gave us. Alrighty? So of course we're going to look at how we can simulate the season using note cards. So what we would do is we would take 60 note cards because we know that we'll take 60 because there were 30 Major League Baseball teams. And each of those baseball teams has 2 pieces of information. It has a spring training win percentage and a regular season win percentage. So each team gets one of those values. So that's what we're going to label. We're going to label 30 with the spring training win percentages for each team. And then we'll label 30 with the regular season win percentage for each team. It's very important that when you're describing what you're putting on the note cards, that you're implying that a number exists. Don't say label 30 with spring training. That doesn't tell me what about spring training you're labeling. Also, someone could write the word spring training on 30 note cards. No, you're specifically, make sure that you're very specifically mentioning like a number, a value. Okay? Make sure that you're describing a value. So here, the spring training win percentage would be a number for each team. A regular season win percentage would be a number for each team. Okay? Now that we have these numbers, we don't want to shuffle all of them together. We're looking at the relationship between this variable and that variable, or the potential relationship, I should say. So that means you want to preserve the integrity of each pile. So when you say shuffle, you have to make sure to say to shuffle each pile separately. Shuffling each pile separately, again, preserves the integrity of what was a spring training number and what was a regular season number. Then you're going to pair each card from the spring training pile with a card from the regular season pile. Now you have different matches of a spring training and regular season. So then now that you have those values, you can calculate the correlation. And again, when we calculate, that's going to be an observed correlation. So you're going to calculate the correlation for this randomized data. So calculate the observed correlation for the randomized data. That gives us one dot on our dot plot for the correlation. And so we want to repeat that many times. Okay? So this is how you would discuss simulating. All right, so anytime it says, how can you simulate the distribution of the test statistic, these are the steps that you should practice writing. So after the simulation, which assumed no association because we were so random, we can see if there is enough evidence to show that there truly is an association, or if the observed association was because of random chance. So as our test statistic, when we estimate the p-value, in this chapter, our test statistic is going to be that observed correlation. In the past, we've had test statistics of difference in proportion, longest streak, number of streaks, difference in standard deviation. In this chapter, our test statistic is the observed correlation. So that's like the name or the description of our test statistic. And we also want to give the value of the test statistic. The value of the test statistic is whatever was calculated. And on the front, remember they told us that that value was 0.45. So that's going to be our test statistic, the observed correlation of 0.45. Okay? So now we use that to calculate our estimate for the p-value. Remember, to find our p-value, we're going to look at the number of dots that we see that are greater than or equal to our test statistic of 0.45 over the total number of dots. It told us there was 100 trials, so that means that there were 100 dots. And so let's carefully read our dot plot here. So this is 0, 2, 4. So that means that this would be 0.3. So that means this would be 0.35. So this would be 0.45. So again, we'd want to draw a line at our test statistic and think about everything to the right. And we want to see how many of those values there are. But what we see is that there aren't any values in the simulation that gave us that. That means that our p-value for this problem is 0. And what that does is it just gives us super strong evidence, as we'll discuss in a minute. So let's interpret the p-value. Remember, when you interpret the p-value, you talk about the specific test statistic and random chance. So what we can say is that there is a 0% chance of getting this test statistic, which was an observed correlation of, in this case, we looked to the right, so we'll say at least, and then our value that we looked at was 0.45, just by random chance. So there's a 0% chance of getting this test statistic just by random chance. This test statistic is specifically an observed correlation of at least, since we looked greater than or equal to, 0.45. Again, the observed correlation, that's the name of the test statistic. And then the 0.45 is the value of the test statistic. So always include those features in the interpretation of the p-value. Then we can draw our conclusion. Remember that the higher the p-value, the more likely it was that it was random chance. So since our p-value is 0, that means, again, like we said here, there's no chance of getting an observed correlation of this value just by random chance. So that means that this is very special. So our conclusion would say that since our p-value of 0 is less than 0.05, remember that's our cutoff for being special that we've used throughout the semester, that means that we do have, and you don't have to put this, but when it's 0, we have extremely convincing evidence that this was special. We have extremely convincing evidence that our alternate hypothesis is true. So that the true correlation between spring training win percentage and regular season win percentage is positive. So again, our p-value is less than 0.05, so we do support our alternate hypothesis. Our alternate hypotheses, well, both our hypotheses should discuss the true correlation. And again, the alternate was that something special happened, and that was not having no association, but a positive one. So that's really the gist of our hypothesis test for Chapter 10. So, like we did here, if someone concludes that the true correlation between spring training winning percentage and regular season winning percentage is positive, does that mean that winning games in the preseason will cause a team to win more in the regular season? Explain. Well, what's the key word here? Cause. And we know that even though this, like we accepted this and we had very convincing evidence that the correlation was positive, that does not imply anything cause and effect. So we have to say no. Remember that associations, and again, this is a sentence you can use over and over, that associations only imply trends and tendencies. So yes, we would expect a team that won more in the preseason to win more in the regular season, but we cannot say for sure. So these are not definite or cause and effect relationships. Okay, so this is kind of bringing the hypothesis test that we've done in Chapter 2, Chapter 3, and Chapter 7 to Chapter 10. So if you have not figured out how to interpret a p-value or draw a conclusion, here's your last chance before the final exam, okay? So that's it. So let me know if you guys have questions. Thanks.